introduce our panelists. This is kind of a continuation of the last panel. So some of your questions are going to be very much on target for this group of people, but we'll try and get you out of here at 3:05. My name's Don Dingy. I'm the editor of Embedded Computing Design, and we've been talking embedded for the last 3-4 panels here with things like smart meters and embedded software, my friends from IBM and Green Hills. And I want to introduce 3 panelists that we've got here to kind of continue this conversation. We have Sami Nassar, who is the Global Director of Product Marketing and Business Development for NXP, the Identification Business Unit of NXP. We have Chris Dunn, who is VP of Technology for Information Assurance at SafeNet. And we have Craig Rawlings, who is Senior Director of Product Marketing for Certicom. Hopefully those are the 3 gentlemen we have here.
Yeah, it's actually Jim Alfred, Director of Product Management for Certicom.
Okay, sorry, Jim, thank you.
I do a good Craig impersonation, though.
We can do a Craig impersonation. Thanks for your patience. Like I said, we'll try and keep us on track here. We've been discussing embedded for the last 3 panels or so, and I think you've got a pretty good idea. Embedded encompasses quite a few things. It encompasses the smart meters, and it encompasses many of the control devices in the utilities. But I wanted to ask the panelists and get a response from each of them, you know, how do the issues with embedded systems in a utility context differ from what you're seeing with non-embedded systems? And let's start with Jim and see if we can come this way.
Well, I guess one of the, maybe it's actually common, but you're actually using, OEMs are generally using components from another number of vendors, and they're trying to put these together into secure systems. And each one of those components impacts the security of the system. And then the system design, obviously, is critical as well. So you have to look at a lot of different elements when you're designing these, and again, these distributed embedded systems.
Yeah, I think we mentioned a lot of the outsourcing that's going on, and we'll get to that theme a little bit later. Chris, same question.
So really, some of the main factors have already come up today, and that's the constraint of the devices due to the cost limitations that you want to use in the devices. And what was also mentioned this morning was that some of these devices are the subject of nation-state attacks. So you really, it's kind of amplifying the challenges. Like, you need to build a really inexpensive product, and yet your adversary has huge buckets of money that they could use to attack it.
Wait, I thought this morning we were saying that only denial of services attacks were coming and that the devices weren't worth the effort. Is that not true? Well, devices may be worth the effort?
Well, that depends on the overall architecture of a system.
Yeah, it definitely depends. Sami?
You know, the security is layers. You know, you have to start with the basic hardware, then you top on that the board, the software, the system, and with all it's the stages of it. And you cannot say that security is only in this point. But one sure thing, if you have one weak point in this whole chain, this is where your security is capped. So embedded hardware is essential. Without that, the whole thing could be too much money spent unnecessarily. You have to look at if you're looking at your threat model, the consequences of a hack is too great. I don't think we should get cheap on an extra couple of bucks per device to make sure that we put the latest and greatest technology into the embedded electronics, and we should copy the other markets, like in banking, like in telecommunication, like in ID, like passport and so on, that used many years of their progression to compile it in small hardware that can be embedded and used effectively in these systems.
So what would you say about the sophistication of these attacks? Jim, let's start with you. How difficult, what are we seeing, I guess? We all know about the denial of service attack against a router, but what kind of sophisticated attacks are being put against an embedded device that maybe you're not seeing against a conventional IT network like port hammering or something like that?
I think we had in the last year or so, obviously Stuxnet's a good example of, is that an embedded device? Well, it's kind of an embedded device that was used in deploying the attack, but we've seen attacks where it's over-the-air update for a wireless mesh network, where there are vulnerabilities or flaws in the lower level design, the random number generator that led to potential attacks in systems. So there are a lot of, again, subtle attacks because of the network architecture, the distributed nature of the system. How important are some of those in terms of, do I need secure hardware, a smart card in those devices? Or if I compromise one meter, what does that mean to the system? It probably means something to the billing system, but I'm not sure it means something to the security of the overall system. So it depends on kind of what are you getting out of these specific attacks, right? So it comes to system design and what are the real threats against the system. But again, over-the-air update and propagating bad code that way, that's a serious problem.
We'll get back to that one too. Chris?
I think it's also not unreasonable to be concerned about the issue of embedding malware during the development process or during the manufacturing process at contract manufacturing site. So you have to deal with that whole supply chain of making sure that when your code, when it's developed, that's going in your devices, has had 4 eyes looked at it and reviewed. It's digitally signed and shipped to a secure device, a secure island of trust in your contract manufacturer, so that as it's injected inside your products, that you have that level of trust in the whole chain.
Okay, Sammy?
Absolutely, I totally agree with that. You have to, build your trust based on something that is, protected from the production level all the way to the deployment or embedding in the device. So you need to have this root of trust into your system, otherwise this whole thing could collapse. And while talking about the implication of an attack or a breach in the system, we can think about the safety issues, which we've been discussing all day today, and the repercussion of those safety issues or reliability of supply. But you have the other side as well, which is revenue protection. When your meter can run both direction, it's like an ATM machine. So what you'd think is, why not have the same security level than an ATM machine? So right now we're trying to build something that is at really rudimentary level of security for systems that are very sensitive in terms of safety, reliability, and revenue protection. To go back into what type of attacks we can expect to see in this market as it deploys, because right now it's still early stages. We do see a lot of them, attacks, for example, on ID, on bank cards, and so on, going at the level of decapitating the chip and reading what's inside of it, and there just need to be protection against that. A very common attack on operating system with software is one of them is called DPA, which you stuck an antenna even outside the meter or outside the cell phone, and you read the EMI vibration, and based on that you can detect what's inside and the keys. So there's a lot of techniques that have been built up over the years to counter, to protect against this side attacks. And those need to be available from the get-go because this infrastructure will be there for 10 years, 11, 12. This is what we heard this morning. But even in security time, this is eternity. Every 2-3 years we discover a lot of ways of protecting the systems, and we cannot afford to start from the get-go with an architecture that don't take the best in class today in terms of security and roll with it and make it up to par with the other industry at all time. So we cannot start with a weak architecture or system that lacks hardware security.
So Chris mentioned something about the trust path and being able to validate that a device is really the device that you A, wanted on the network, and B, expected on the network, right? Could you tell us a little bit more about how specifically that could be done? How can you validate that a device is really the device you expect it to be? It's not a counterfeit, it's not a Trojan, it's not something that you don't want in there.
Well, I guess one way of doing that is through a full chain of control from the production of the software right through to the product around digitally signing what is going into that product and controlling the manufacturing environment in which that happens, and then using a PKI to verify the identity of that device.
Okay. Sammy, you got a comment on
Yeah,
that?
I can complement that, that we are, you know, we have apparently the same view on this, this one.
Read your notes.
And this is very, very interesting. Today, like the whole security resides on the fact that, you know, you are who you pretend to be. And this is the root of trust. So the chip, when it leaves the manufacturing facility, have a unique identity and should be able to prove that its identity at all time. And this is the PKI that just been mentioned right now. And so what we do typically for other industries is we inject these keys at the level of the wafer test. So before even we cut it into dies and put it into plastic packages, there's a unique identity that's embedded there and protected at all time and accessed only through algorithms like the PKI to ensure that this chip is who it is pretending to be. Now, as the life of the device itself and the chip goes forward, you add layers of software and you update this profile into the chip by, you know, saying, okay, I made the A, B, C update and it's running this operating system, and this is a signature that verifies that I'm an authorized entity that made these changes and store it in the chip. So at all time, you can question that chip to see what type of profile needs to run on the end device, if it's a meter or another card of some sort, and be able to verify through its life all the changes with the signature that of the authority that enabled or permitted these changes.
Sounds like the social networking problem. We are who we say we are out on the net. Jim, give that a try from your perspective. Cycle of trust and how things come together.
Yeah, I think you said it fairly well. So we actually do deploy solutions, again, in the smart meter space and in the silicon space in general, where we create roots of trust on silicon chips. I mean, you talk about the real interesting vulnerabilities. I think they're even in silicon mask design, and are your masks who they say they are, right? So if you're outsourcing or you're offshoring your silicon, are you getting the right masks back when you do your manufacturing? But we take it as well from the keying and provisioning identities onto silicon, and then managing that silicon securely end to end. So we take it another step and make sure that that whole transport layer, whenever you're provisioning keys and managing keys, that's done securely, because it's not just about the identity of the chip, it's about the identity of the entity managing that end application. And
Right,
so that's
so
where we focus on.
So you're working with the global fabs like TSMC and those kind of guys to...
Well, we're working with the chip vendors that work with them.
Okay, okay. What kind of algorithms do you see in play here? You mentioned PKI, but is that everything? Are there some other things that come to bear, or is it strictly a PKI strategy?
You can do it with a PKI, or you can do it with just a public key system where you're managing public keys. But generally, that's the way people would manage secure identities. It's also about the security protocols that you're using to provision. It's about the access controls. Again, when you have an authority, say the manufacturer or the operator that's controlling a system, how do you control access to that system that's doing the device management?
Interesting. So we had an amusing conversation in the last panel about absolute security. I thought it was amusing, at least. But earlier in the morning, we kind of had the counterpoint to that, it's a moving target, and you can't regulate this stuff, and people are going to keep discovering things, and they're going to keep figuring it out. And all of you are from the embedded side in one degree or the other. You're used to dealing with long life cycles. How are we balancing out that need to have technology be stable and designable, and yet be not vulnerable over time? I guess I want you guys to comment on the Travis idea from earlier this morning, that the vendors should be talking, the silicon and software vendors should be more forthcoming about security-related errata, and I wanted to explore that with the three of you and see how you felt about that position. Is that a real issue, or is that something else going on? Sammy, we'll start with you on that one.
Actually, so there is a minimum that needs to be regulated to a certain extent, and what you regulate is the minimum. You know, it's like, what is the minimum accepted? And then you need to build on top of that in terms of errata, or in terms of testing procedure or certification houses where you have to get your system checked. And as discoveries happen, you improve your test or qualification requirement to incorporate this new, discovery of a security attack. But at least, like, if, for example, we look today, if regulators do not come in and say, well, we cannot accept lower security than what is being utilized today in banking system, or what is utilized today to do ID, or like the passport, or in similar things, the industry can, drop the level very low. So we have to have a minimum in terms of regulation, and then build on top of that through the certification houses. So saying, okay, we have to be compliant with FIPS 140-3 or something, or we have to comply with common criteria in Europe, or we have to comply with this, security accredited certification that has been rolling for X number of years.
Great. Chris?
So I have a similar view, but I look at the minimum or the certification process as providing assurance that a product or solution has met what's the body of knowledge that's out in the industry today. And then if you move on to penetration testing, is going on to explore things that have not been discovered in different attacks. So you definitely want to do both of those things.